Section 10.3 Test for Homogeneity. The chi-square test for homogeneity of proportions is used to compare proportion from two or more populations. Look at the definition. In a chi-square test for homogeneity of proportion, we test whether different populations have the same proportion of individuals with some characteristic. From last session's test of independence, we only have a one populations, but we do have a two variable, and we want to know if these two variables are dependent or independent. And for this session's test of homogeneity, we do have a two or more populations, but we only have a one variables, and we want to know do they have the same distribution for this variable. Let's look at this example. A company wants to estimate the homogeneity of optotypes purchased among 3 states. Is there sufficient evidence at the 5% level of significance to conclude that the distribution of optotypes purchased differ among the 3 states? The data is shown below. So you can see we do have a 3 population that is from 3 different states. And we only have a one variable talking about the optotypes. So we want to know do they have the same distribution from these 3 states. Let's look at the notation. The notation will be similar to the test of independence. O, observed frequency. So we're doing the survey, and then we're gonna write down how many people in California will purchase the car, and we write down the numbers here. So this is gonna be the observed frequency. Expected frequency, we do have the same formula to find it out, the expected frequency. And then the R represent the number of the rows in the contingency table. Again, when you count how many rows in the contingency table, do not including the labels and the total. C represent the number of columns in the contingency table. This is the instruction how to use your TI-84 calculator to perform a test of homogeneity. Basically, this is exactly the same thing with the test of independence. Now, look at the procedure for testing of homogeneity. We'll be using the chi-square distribution. So first, verify the conditions. Random sample, independent sample, large sample, so expected count is at least 5 in each cell. Last one, categorical data. So pretty much that's the same condition with test of independence. Finding expected frequency. Same formula, just like the test of independence, using the row total times column total divided by grand total. Step 3. Identify the null and alternate hypothesis. So we do have 2 or more populations, and we want to test if the distribution of the populations are the same. Alternate hypothesis. The distribution of the population is going to be different. Test statistic, same formula, but we'll be using the calculator to find the test statistic. Step 5, find the p-value and interpret the p-value. Before you find the p-value, find the degree of freedom. So this is going to be the contingency table. The degree of freedom will be equal to R minus 1 times C minus 1. And chi-square distributions always skew to the right. And then we find the test statistic from the step 4 already. So the p-value will be the area of the white tail. So use chi-square CDF, test statistic, lower value, and then upper value, that will be 1D99. Then the degree of freedom. If you find the p-value that's less than or equal to alpha, you're going to reject the null hypothesis. So when you reject the null hypothesis, we believe that the distribution of the populations are different. If your p-value is strictly greater than the alpha, we fail to reject. We do not have sufficient evidence to support the distribution of the populations are different. And then conclusion. Every time when you guys draw the conclusion, make sure you guys read the claim statement. Interpret in the context of the scenario. For example, if you reject the null hypothesis, we're gonna say there is sufficient evidence to conclude the distributions are not the same. If you fail to reject, you're gonna say there is not enough evidence to conclude that the distributions are different. Okay, now let's try to do the example together. A company wants to examine the homogeneity of optotypes purchased among the three states. Is there sufficient evidence at the 5% level of significance to conclude that the distribution of optotypes purchased differs among the three states? The data is shown below. So first, I need you guys fill out the contingency table, find out all the total and the grand total. Check your work. And then verify the condition. So we assume that will be the random sample and independent sample. And then the expected frequency is at least 5 on each cell. Okay, you're gonna double check with this one after the step 2. And this is gonna be the categorical data. Finding the expected frequency. So for example, we are working on the California with the car. So we're gonna use the row total 248 times the column total 171 and then divided by the grand total 475. You should get 89.2. And then second one. So row total times column total divided by grand total. You should get 98.7. Okay, I want you guys try to do it by yourself. Okay, check your work. Okay, step 3. Identify the null and alternate hypothesis. So we want to test if the distribution of the autotypes purchased will be the same across the 3 states. Okay, they do have the same distribution among these 3 populations. Alternate hypothesis. The distribution of the autotypes purchased will be different from these 3 states. Okay, test statistic, let's do it together. Okay, go to second matrix and then go to edit, enter, and then we have 2 by 3. Okay, so 2, enter, 3, enter. So I'm gonna input it 90, enter, 97, 61, 81, 92, and then 54. Okay, right? So click on the stat, go to the test, go up, choose the chi-square test, just like the test of independence. Enter. So I just input my observed frequency and expected frequency, they're gonna calculate it. And then go to calculate, enter. So you will have the test statistic, you also have the p-value here. Okay, so write down your test statistic. And then p-value will be the area of the right tail. Okay, now let's find out the degree of freedom. We do have a 2 row, so 2 minus 1 times 3 column, 3 minus 1, which is going to be equal to 2. Okay, so degree of freedom equal to 2 here also. And then chi-square CDF, lower value 0.1038, upper value 1D99, and then degree of freedom, that will be 2. Use your calculator again, you should get this 0.9494. Okay, second, bars, chi-square CDF, 0.1038, enter, 1D99, degree of freedom is going to be 2. So that's a 0.9494 as well. Okay, so the p-value is going to be greater than the significance level, so we fail to reject. Okay, fail to reject means we do not have sufficient evidence to show that the distribution of opto-test purchase is going to be different among the 3 states. Okay, example 2. I want you guys try fill the totals, verify the condition. If you can, try to find out the expected frequency. Okay, let's do the work together. You want to examine the homogeneity of opinions on gun control among 3 political affiliations: Democrat, Independent, and Republican. Is there sufficient evidence at the 5% level of significance to conclude that the distribution of opinions on gun control differs among the 3 groups? The data is shown below. So you can see we do have 3 populations. Okay, the Democrat, Independent, Republican. This is the 3 populations. But we only have one variable. The one variable talking about the gun controls. So this is going to be the test of homogeneity. Now, fill up the total. Check your work. Okay, verify the condition. We assume there will be random sample and independent sample. And then expected frequency, at least 5 in each cell. Again, you're going to double check after you finding the expected frequency. And then last one, categorical data. Okay, find the expected frequency. So the first one, the Democrat, yes, that will be 45, the row total times column total, divided by grand total. So you should get 13.1. So try to do it one by one. Check your work. Okay, now identify the null and alternate hypothesis. So no hypothesis, there is no difference in distributions among political affiliation as it applies to gun control. Okay, these three populations will have the same distribution. Alternate hypothesis, there is a difference in distributions among political affiliation as it applies to gun control. Okay, test statistic, I want you guys try to use your calculator. You should get 19.973. Okay, so chi-square distribution skewed to the right. P-value will be the area of the white tail. So find the degree of freedom first. Okay, you should get degree of freedom equal to 2. And then chi-square CDF, lower value, upper value, and then the degree of freedom. You should get a really small p-value, 4.6 times 10 to the power of negative 5. When you guys use the graphic calculator, pay attention. You could see 4.6 and then e negative 5 at the end here. So this is the scientific notation. It means I will move your decimal point 5 space to the left. Okay, so you can see 1, 2, 3, 4, 5. Okay, so the p-value is very small. And when you compare with your significance level, that will be less than. So we're going to reject the null hypothesis. So reject it means we do have a sufficient evidence to conclude that there is a difference in distributions among political affiliation as it applies to gun control. Okay, we are done for the example. Now we're gonna compare the goodness of fit test, the test of independence, and the test of homogeneity. So you can see from this table, for the purpose, the goodness of fit test, they only have a one variable and then one sample. Test of independence, they do have a two variables but only one sample, and they want to test if they are dependent or independent. The test of homogeneity, we only have a one variable, but we do have a two or more samples. Okay, so when you guys with the questions, you have to be really clear which test you're working on it. They will have a different hypothesis for this three tests. Okay, let's look at the example with each scenario below and determine whether it describes a goodness of fit test, test of independence, or test of homogeneity. Write your answer next each scenario. A marketing team surveys customers from 3 different cities to see if their favorite soda brand distribution is the same across location. So first, 3 different cities. They talking about they do have a 3 samples. Okay, 3 samples. And then they only have a one variable talking about the favorite soda brand. So this is gonna be the test of homogeneity. Okay, write it down. We only have a one variable, the soda brand, and compare across multiple populations. Second one, a research wants to know if there is a relationship between students' preferred study method, the group, solo, online, and their academic majors, STEM, arts, and business. So you could see we only have a one sample, okay, talking about like the students, but we do have a two variable. First one will be the study method. Second variable will be the academic majors. So this is gonna be test of independence. Last one, a teacher believes that students choose their favorite school subject, math, science, history, English, in equal proportions. So surveys a class and wants to test if the actual preferences match this assumption. So they do have a one sample, okay, the students, and then they only have a one variable talking about the school subject. So this is gonna be the goodness of fit test. Okay, that's it.